In the south central U.S., the coldest morning of the season. We recorded 48 degrees here, Dallas recorded 52, and Houston 57. That's due to that Pacific air that's flowing in from the northwest and really displacing all of that tropical air. Let's check it out on the precipitable water. And that's definitely a good chart for visualizing the effect of this air mass. This is all dry, cool air that's moved in from the Pacific Northwest and Western Canada. And there you go, there's the smoking gun. These are the trajectories into the Dallas-Fort Worth area. You're seeing trajectories arriving at DFW at 500 meters, which is about 1,500 feet, 1,000 meters, which is about 3,000, and 1,500, which is up near 5,000. And you can see the origins are all from British Columbia, the Gulf of Alaska, and ultimately Alaska itself. Down to the south, that's all tropical air. And for comparison's sake, there's the trajectories arriving at Wilmington, North Carolina. That's all coming from the tropics, south of Bermuda. And guess which way it's moving? It is out of here. Now, if we run that back, we do see one very interesting feature up here in Alberta. That's a little Alberta clipper that's diving southeast, and you can see that moving into the Dakotas this evening and then down into the Ohio River Valley tomorrow. So what's going on here is we have an area of pressure falls. I put a little minus there to indicate that. And up to the north, an area of pressure rises. That's kind of a couplet coming down from Canada. So if you watch this area back behind it, you can see this big high building in, and that gives us a reinforcing shot of cold air. All right, let's take a look at the weather out there. Looks a little bit different, doesn't it? This is Siberia. I wanted to show some of the cooling going on out there. This is a huge continental area at high latitude. This line right here, this is 60 degrees north, the same as Anchorage, and there's 70. So there's a lot of potential here for radiational cooling, and obviously we're all the way down into the 20s and 30s. If we look at typical temperatures up in Yakutsk, which is a city up there, so let's take a look at the typical daily high temperatures. In August, they're running about 71 degrees, but by the time we get into mid-October, they're usually about 26, and they just keep falling until they're about minus 30 Fahrenheit by December. So obviously things are changing really fast up in that region, and we're starting to generate cold air masses. Some of them do reach the U.S. indirectly. These air masses move out into the surrounding waters of the Pacific. They generate stormy conditions, modify, and gradually the regions out there cool dramatically also. And some of that does make it into North America. And that's just a quick look at what the fronts look like. Well, obviously, it's substantially warmer in the Pacific Northwest. Conditions this afternoon dominated by this huge ridge extending all the way from British Columbia down towards Colorado. So this is all high pressure here, and as a result that gives us a northwesterly component in the plains, and on the other side we've got a southerly component. So we would expect conditions to be a little warm on the west coast. And I do see there's a low pressure area off the coast of Oregon. Don't see much definition on that yet, but temperatures do look pretty warm along the Washington coast. So I'm not entirely sure that we have got a front to the southwest. You could go out on a limb and maybe put a front kind of in this area. but I'm not too sure about that just yet. We would have to look at more data. Things looking pretty nice in that area, just a little bit of smoke getting pulled into that low pressure system off of the Oregon coast. And elsewhere, looks pretty clear and dry. Also a nice day in the southwestern U.S. There's that northerly flow in the central plains. And then off the coast of California, that marine layer lurking right off the coastline. A lot of stratus and stratocumulus lurking off the coast of San Diego, Los Angeles, Monterey, and San Francisco. There's the weather map for the southwestern U.S. Looks like we've displaced that heat low. Typically, we find that in southwestern Arizona. That looks like it's down into the Gulf of California now. Already got 100 degrees there along the coast. Some of that heat still lurking inland, already up to over 101 around Palm Springs. But we've got that northerly component still through Las Vegas and Safford in Tucson showing east winds, and that's a result of that modified high pressure warming over the very hot terrain in Arizona. And yeah, that high pressure area extends all the way down into West Texas. So that's a continental scale feature. The southeastern U.S. showing that Pacific front on the move through Georgia and the Carolinas. Florida getting a pretty significant change in the weather there around Tallahassee, and back to the west there you can see the air mass is not really that cold. It is continental polar, maybe maritime polar, somewhere in between, but it is heavily modified. That's why I'm not putting a whole lot of those markings down here. But out to the east, though, yeah, that's a tropical air mass for sure. And due to these very high dew points, you can see 74, 75, 73. That's a potent situation there for showers. We can see that on the satellite loop. Numerous showers breaking out, and the air mass there is very uncapped, so we're getting numerous cells developing. And there's the radar for Tampa Bay. There's Tallahassee, Valdosta, Macon, Charleston, Columbia, Spartanburg, Blacksburg, State College, and even Burlington, Vermont. And there's even stuff out ahead of it at Wilmington. Fortunately, SPC just has a marginal risk out from Florida to Virginia. And in the northeastern U.S., things are going downhill with the approach of that front. Out ahead of it, some pretty decent weather from Maine down to Boston, New York, and Washington, but things are going to get wet. And back behind it, you can see the extensive cold air advection, stratocumulus, and cumulus in Michigan, Chicago, Indianapolis, all the way up to Sault Ste. Marie. And that leaves us with the northeast U.S. High pressure out to the west associated with that Pacific system, and low pressure up in Quebec. Now with that front going through Pennsylvania, New York, Virginia, now you might be looking at the 76 at Philadelphia, contrasting with the 70 in New York, and you might put a warm front there, but you need to look at the big picture. If you go up to the north, you find 79 in New Hampshire, 80 near Mount Washington, and 82 up in the St. Lawrence River Valley, 81 in New Brunswick. So this tropical air mass extends way up north, which means you have to put the warm front up there in the Maritimes. So what's causing these cool conditions here? That could be outflow. You may certainly draw a feature if you can kind of identify where the convection is. That's probably what's happening there. Also, you could have the sea breeze working inland. You can see at Cape Cod, 70 degrees there. That's probably what's happening there. That's the influence of some of the clouds offshore, some of the cooler air. But out to the west, yeah, we got a couple of cold air advection troughs. I can pick out one kind of in there. There's probably another one, maybe running something like that. So kind of a series of little waves moving through the flow associated with that cold air advection coming out of Canada. Okay, let's take a look at the weather over the next 24 hours. This is the map for tomorrow night, Wednesday evening, and we can see that there's this high pressure area up here in northern Canada. Make that a little easier to see. We do have that low pressure area out there in the Canadian Maritimes, and this is a vast area of cold air advection coming down from Canada. So there could be a reinforcing shot of cold air, perhaps along that line, maybe kind of transitioning into a stationary front along the Rockies, kind of like that, and then a very weak warm front. So this area here where you can see the boxes kind of forming up, like there's a box between the thickness and isobars, that's an area of cold air advection, and the smaller the box, the more intense the cold air advection. So we can kind of identify that cold air advection source. Do we have a box down here? Not really. Boxes up here? Yes. In fact, there's quite a few of them. Lots of cold air advection in Montana, northeast Wyoming, and Saskatchewan. So this could be another reinforcing shot of cold air, almost another baroclinic zone. I'm not sure if I want to call that one yet, but that could be another one on its way down, possibly with a shortwave associated with it. And then we have another trough up to the north. That's another cold air advection trough. All right, then let's see, for Thursday evening, see if I can pull that out without destroying stuff. There comes that high pressure area coming on down from Alberta. Cold air advection is shifted down into this part of the country, lower Mississippi River Valley, West Virginia, and this cold air advection area up here has kind of backed off because the thickness lines are parallel with the isobars. So we can just go ahead and ignore that. In fact, there's a little area of warm air advection up here in Alberta and Saskatchewan because the flow is coming up from the south like that, and you're bringing up this warmer air into those latitudes. So that is probably where the air mass is recovering. But yeah, there's our little front down there in Georgia. I think we can go ahead and maybe classify it as a new front. So again, this is Thursday evening. That's our new front, Alberta Clipper, coming on down into the southeast U.S. And then for Friday night, got some bugs to work out here. Okay, there's our picture. Vast high pressure area covering all of the eastern U.S. Cold air advection on the east coast. That's one thing we used to do in the Air Force. We would identify the cold air and warm air advection regions kind of like that. And then you can see the box method gives you a warm air advection region across the Central Plains, so the air mass is recovering there. But right here, there's a little area of cold air advection coming together. So this could be a new area of frontogenesis. Actually, probably should use the colored pencil for that. So that's a new front coming together there, a new baroclinic low. And very likely that's moving along the thickness lines towards the southeast. Again, this is Friday evening. And this is being driven by high pressure up in Alberta. All right, and that's all I've got for this edition of Forecast Lab. I appreciate you all watching. And I did say this before on yesterday's supporter stream, but I wanted to thank Adam Rolfs, Mike Lammers, Brian Nelson, and Abe Moscow, our first Patreon supporters in about a week or two. And as a reminder, we do have a free giveaway for the Instability Skew-t and Hodograph Handbook, which is about a $30 book. I'm going to be giving one of those away to a new Patreon supporter for September. So if you've not subscribed yet, now's the time. There's the link on how you can do that. So there's still some time to do that, and you'll get automatically entered into that drawing on October 1st. Okay, well, I hope you all have a great Tuesday. Is it Tuesday already? Yeah, it is. And we will see you all tomorrow. Take care. Bye-bye.